All right, so for the first question on checkpoint 21, it says that Mr. and Mrs. Jones each recorded how much money they spent on lunch for 5 days. The results are shown in the table below. The question is asking us what is the difference between the mean amount spent by Mr. Jones and Mrs. Jones. So we want to know what the difference between the mean is from what both of these two people spent. So if I am asked to find the difference between the mean, well, I first need to figure out the mean. Right? Remember, mean is another way of saying average. So to figure out the average for Mr. Jones, I would add up all of the money that he spent. So it looks like he spent $5, $6.25, $5.75, $6.50, and $8. So if I were to add up how much money Mr. Jones spent, so 5 plus 25 plus 5.75, 6.5 plus 8. Mr. Jones spent $31.50 all week. And to find the average, I need to divide that number by how many total numbers I added together. So I would have 31.5 divided by what? How many total numbers did I add together here? 5, right? I added together 5 numbers. So if I divide that by 5, oh, whoops, what happened? How do I go back? Now let me just close and reopen Paint because I'm not 100% sure on what I clicked and how to get back. There we go. Okay. So we had 31.5 for Mr. Jones, and we divided it by 5. So he spent an average of $6.30 each day for lunch. Okay. Well, now let's look at Mrs. Jones. For Mrs. Jones, to figure out how much on average she spent, I would add up all the numbers here and then divide it by 5 again. So 550 plus 7 plus 625 plus 575 plus 775. So if I add up all of these together, I get $32.25. And again, we're going to divide that by 5 because that is how many numbers? I did it again. What is happening? I don't know how to get this back. I don't. All right, I'll try it one more time. All right. So if I take 32, I'm getting really annoyed with myself because apparently if you type in a 2 on 3D Paint, it gives you this. Does anyone see where I need to go to like fix this or what I need to do? Ah, I figured it out. It's just up here. Okay. Well, now I don't feel as aggravated. Cool. Okay. All right. Let's hope I never do that again. Cross my fingers. All right. Click in the calculator to type. Right, 3.25 divided by 5. There we go. All right. So Mr. Jones spent 30, oops, not 30, spent on average $6.30 for lunch. And Mrs. Jones spent on average $6.45 for lunch. So to figure out the difference, right, in their means or their averages, what would I do with these two numbers if I want to figure out what the difference is? Jordan says it's 15 cents. How'd you get that 15 cents? You subtracted. Perfect. Yep. So if you take that 6.45 and subtract it from 6.3, that will give you the difference, which is 0.15. So the difference between their average amount that they spend for lunch would be 0.15. All right. Next question that I have is the mean of the following data set is 509. And we want to know what's the mean absolute deviation. The first number is 419. The last one is 612. I'll give you guys a second to find it and let me know when you are ready. Awesome. All right. So this question thankfully tells us what the mean is, right? So that takes out one step of what we have to do to figure out mean absolute deviation. So remember, your mean absolute deviation is kind of like the average of your average. This 509 is the average of all this data. So we need to figure out how far away are each one of these numbers from our average, which is 509. And we're going to do that by subtracting. So 509 minus 419, 509 minus 450, 509 minus 462, 509 minus 499. Now here, since 520 is bigger, I'm going to start switching the order because I want my numbers to always be positive. So you want to always subtract your bigger number first. And then 612 minus 509. All right, so now we just have to type all of this into a calculator to get all of our numbers. And when you guys are typing this into a calculator, please double check your numbers before you move on to the next one, because if you type in one number wrong, it could make a big difference. So just double check when you are subtracting. Jordan, you said you did not do that. What did you not do? The bigger number first, yes. So make sure that your bigger number is always first. If you do it where your bigger number is not first, it's not the end of the world. It will just give you a negative number. Like say on this last one, I did 509 minus 612. Do you see how it's the same number, just one is negative, right? As long as you yourself know that when you're finding your distance, your answer is always positive. You can do it this way, but just make sure that when you write it down somewhere, you take that 103 and treat it as a positive number. Does that make sense? Okay, perfect. So make sure that all your numbers are positive. Alrighty. So I have now all of my new numbers, right? This is how far each one of my data sets points is from my mean. So from our mean absolute deviation, I just need to find the average of everything I have circled here in purple, which is all of the distance. So I'm going to add them all up and then divide them. Oops, I forgot a 0. See, double check, because that would have made a huge difference. And then I put the 0 in the wrong spot. Triple check could make a big difference. There we go. Let me double check my numbers one last time. Perfect. So when I added everything up, I got 412. And I'm going to divide that by 1, 2, 3, 4, 5, 6, 7, 8 numbers, because that is how many I added together. And when I divide all of that by 8, I get 51.5. So my mean absolute deviation for this data set would be 51.5. All right, so the next problem I have is it has this table with theta A and theta B, and then it gives you your mean and your mean absolute deviation. So I will give you guys a second to type in that last one, and then let me know when you are ready with this question here. All right, so 2 different movie theaters tracked the number of daily ticket sales for 1 month and produced the means and mean absolute deviations shown in the following table. Which statement best compares the variability for the ticket sales for the 2 theaters? Okay, so when it's asking variability, that's saying which theater essentially has their starting, like their lowest and their highest point closest together. I'm assuming. Let's read through these answer choices and see if we can figure out what this question is asking for. So this first one says that theater A has a greater variability in daily ticket sales because its mean is greater than the mean for theater B. When you are determining variability, you want to use your mean absolute deviation. Your mean absolute deviation will tell you more about the variability in your data than your mean. If you have the larger your mean absolute deviation, the wider your numbers are spread apart. Like say I had a data set that started at 3 and went all the way up to 150, and I have all these numbers in between. This mean absolute deviation could be something like 57 versus another data set that maybe started at 41 and went to 63. This mean absolute deviation could be something like 12. So the smaller your mean absolute deviation, the closer your starting and ending numbers would be in your data. So theater B obviously has a bigger mean absolute deviation, which means that those numbers are more spread apart, which means that they have more variation because you have a lot wider range of numbers. So theater B has a greater variability in daily ticket sales because its MAD is greater than the MAD for theater A. So anytime you're asked questions about variability or which one of these 2 data sets varies more, always look at your mean absolute deviation for that. Alrighty. We good to go to the next one? Alrighty. So next one I have here is we're asked what is the mean for this data set. So not mean absolute deviation, just mean. And starting number is 122. Last number is 280. For that last problem, Dawson? For the last problem, greater or data set B has a greater variability. There's only one question, there's only one answer that has data set or theta B first and is using their mean absolute deviation. Perfect. And this next question, I feel like you guys should be able to answer on your own. You're just asked to find the mean. So go ahead and type all this into your calculator and let me know what you get for your mean. Remember that mean is another word for average. So you're just finding the average of your numbers here. Anytime you see mean, it is asking for your average. It's okay, you're fine. Let's see, Jordan got 202. I'm going to solve this right now while you guys are finishing up. That's okay, Jordan. So that's why I always triple check when I type them in, because I make mistakes like that all the time too. And it's hard to tell if it's right or wrong when you're looking at numbers like that. So Dawson, when you found your average, what did you get? 198.25. That's what I got as well. Yes. So when you add all of these together and then you divide them by 8, right? Because there's 8 total numbers, I also got 198.25. Perfect. Bravo, Jordan, for finding your own mistake. That's super good. Very nice. Yay. All right, next question I have here is talking about Blake recording the number of minutes he ran on a treadmill for 2 weeks, and data is shown in the table. So it's a very long table with minutes in it. So let me know when you guys are ready, and we can start going over this one. All right, perfect. So again, we're asked what's the difference between the median between the 2 weeks he ran on the treadmill. So here we're asked to find the median. We're asking difference between the median. Median means what? What is, when it says median, what's it asking me to find? The middle, right? Median's asking me to find the middle number. And the best way to find the middle number is going to be to write all of them from least to greatest. Okay, so I'm going to look at week 1 and start with the smallest number and rearrange them to where it goes from smallest to biggest, because you can see here they're just kind of all over the place and they're not in order. So I'm going to reorder them. So 15, 22, 25. Then next smallest one would be 32, 35, 38, and 40. You guys can double check for me too, because sometimes when you're doing this, you accidentally miss one. Whoops, I put a really big space in between that 30 and 5. Okay, I think that I rewrote them from least to greatest. I should have 7 numbers on each one, and I do. Perfect. Okay, so to find the middle, I would 13, 17, 27, 30, 35, 43. Perfect. Perfect. Yay, we got the same ones. So to find the middle, I would cross one off from each end until you get to the center, and you can't do that anymore. So here's 1, 2, 3. So 32 is going to be my median for week 1. And I'm going to do the same thing on the bottom. And 27 is going to be my median for week 2. So I have 32 and then 27 is my medians. If I'm asked what is the difference between these, difference is telling me to subtract them. So all I need to do is subtract these two numbers. And when I do 32 minus 7, I get 5. So the difference in his 2 medians from this week is 5 minutes. 5 minutes. Alrighty, next question. We are asked another question about variability. And we're talking about the height of 2 different volleyball teams. So we have a team A and team B with this table here. So I'll give you guys a second to find this problem and let me know when you are ready. Okay, so the heights of players for 2 volleyball teams produce the means and mean absolute deviations shown in the following table. Which statement best compares the variability for the 2 heights of the 2 teams? So this question is asking about variability, again, like that one we did before. So since it's asking about variability, am I paying attention to their mean absolute deviations or their MAD? Or am I paying attention to the mean? Which one do I want to pay attention to here? The mean or MAD? Not necessarily both. One is more important than the other. It should be your mean absolute deviation, because remember that the smaller your mean absolute deviation is, that means the less variability you have between your numbers. And the bigger your mean absolute deviation is, the wider range of variability that you have between your numbers. So we want to look at our 2 answer choices that are talking about mean absolute deviation and use these to help us figure it out. So we don't want to pay attention to any of the ones that have means, because the mean absolute deviation is what tells us how far or how close apart our numbers are. So between these 2, the team A has a bigger mean absolute deviation. So since team A has a larger MAD, that means that that team has a bigger variability. So whichever option has a larger MAD, that one has more variability. So team A has a greater variability in heights because its mean absolute deviation is higher than the mean absolute deviation for team B. So that is the answer that we would want to pick here. So anytime you're asked a question about variability, remember you're paying attention to your MAD, and whichever one is higher, that one has greater variability. Whichever one is lower, that one has less variability. So let me know when you guys are ready to go on to the next one. Perfect. All right, so next question we have is talking about Funland versus Thrillville. We want to know how many more times per year on average do people visit Thrillville than Funland? Alrighty, I'll give you guys a second to find this one and let me know when you are ready. All right. Researchers randomly surveyed people at two amusement parks, Funland and Thrillville, to find out how many times they visit the park per year. The following data are from the two surveys. Here's Thrillville and Funland. And we want to know how many more times per year on average do people visit Thrillville than Funland. So this question wants us pretty much to find the average of both of these and then figure out how many more times people visit Thrillville than Funland. So I'm going to pull my calculator out so I don't have to write all these numbers down because there's a lot for this one. I want to shrink this down to make it not as weird. So I'm just going to type in all the stuff for Funland first and add them all up and then divide it to find the average. And again with this one, because you have so many numbers, I would double check them before you move on to your division. Right there, I made a mistake. And then let's see how many numbers we have. 15. And then I'm going to do Thrillville as well. How many do they have? T. Alrighty. So my average for Funland was 3, and my average for Thrillville is 5. So how many more times do people visit Thrillville than Funland? If people on average visit Thrillville 5 times and Funland 3 times. How would I find the difference between 3 and 5? What would I do with these two numbers? Jordan, you are correct. How did you get your answer? So if five people, or sorry, not five people, people visit Thrillville 5 times per year and people visit Funland 3 times per year, how many more times on average do people visit Thrillville than Funland? Are you guys still here? It's okay, you're fine. It was just a very long period of silence. I just wanted to double check. It's okay, you're fine. So 5 people on average visit Thrillville and 3 people on average visit Funland. So how would I figure out how many more times people visit Thrillville versus Funland? I would subtract them, right? Which would give me 2. So like Jordan had earlier, 2 is our correct answer here. All right, number 8. Number 8, we have 2 data sets, and it gives us the means, and it also gives us the mean absolute deviations for both of them. We want to know which statement best describes the difference of the means based on the mean absolute deviation. So I'll give you guys a second to find this problem, and then let me know when you are ready. Hi, Ruben. So Ruben, right now we're going over checkpoint 21. Did you want help on a different assignment? Hi, Ruben. Like I said, this is checkpoint 21. So if you need help with something before this, let me know, and when we're done, I can help you out with that. Do you know what assignment you'd like some help with? You don't know? I can look it up if you'd like later. Do you know if you've taken exam 4? And then the rest of you guys let me know when you find this problem so I can start going over it. 21.1. Okay. So I'll go over that as soon as we're done with this workbook. It might take another like 20 minutes for the rest of the problems. Is that okay? All right. So use the data sets to answer the questions. We have our two data sets. It tells us that the mean for data set A is 27.75 and the mean for data set B is 22.5. The mean absolute deviation, or MAD, for the data set is about 7.7 and the MAD for data set B is 7.4. Which statement best describes the difference of the means based on the MAD? Okay. Well, if I were to take these two numbers, right, that 27.5 and 22.5, again, I'm asked for the difference, right? So I'm going to subtract those. Why do I have 5.2 here? I don't know. It should be 7.5. And then it says that my mean absolute deviations, they're pretty close, right? This one is 7.7 and this one is 7.4. So I am going to pretend like my mean absolute deviation is 7.5 because that's kind of in between both of them and it's a pretty rounded out number. So let's subtract our means first. And I get 5.25. If I were to divide that, by 7.5, I get 0.7. And technically 0.7, that is closer to 0.5 than it is to 1. It is only 0.2 away from 0.5 and it's 0.3 away from 1. So the difference between the means is approximately 0.5. So difference between these would be approximately 0.5. So I think this was like one of the problems that we went over in the last workbook. So 21.1 from earlier. This is like one of those. All right, number 9. So here we have another question asking about variability, except this time it's talking about two different families' monthly electricity bills. So I'll give you guys a second to find that and let me know when you are ready. All right, so the monthly electricity bills for two different families for 1 year produce the means and MADs shown in the following table. Which statement best compares the variability for the electricity bills of the two families? So again, we're asked about variability. So which am I paying attention to? If I'm asked about variability, do I care about the mean or do I care about the MAD? Which one am I paying attention to if I'm asked a question about variability? The MAD, perfect. And if I look at the mean absolute deviations for both of these families, family A is 21.2 and family B is 20.9. So do we think that those are pretty close together or do we think that they're pretty far apart? What do we think? Looking at those two mean absolute deviations, are they pretty close together or do you think they are pretty far apart? Well, if I were to write this on a number line, let's say 20 is here, 20.5 is here, 21 is here, 21.5 is here. 21.2 would be about right here, and 20.9 would be here. So to me, those are pretty close. If I were to subtract these, there would only be a 0.3 difference between them. So they are almost the same number. They're very, very close to each other, which means that the variabilities for both of these numbers are pretty much the same, which means that the bills for both of these families are going to vary about the same as well. Since our mean absolute deviations are very, very close to each other, it means that one family won't vary more than the other. They're going to vary about the same. Alrighty, questions on this one? Alright, so next one. Hopefully it'll load. Alrighty, next question gives us two data sets and we want to know which statement best compares them. And it tells us that the two different means for the two different data sets. We are asked to compare them. And then let me know when you guys are good. Dawson, are you ready as well? All right, I'm just going to start going over it and hopefully double check the question while I'm reading it. So we have these two data sets here and it gives us the mean for both. And we want to compare the data sets. So we want to know which of those statements best compares the data sets. Well, the first option says that the mean of the two data sets are approximately the same. Well, they're not really close to each other, right? 27.5 and 22.5 are pretty far apart. So I would not say that they are about the same. The next question is all of these next ones are talking about variability. And remember, anytime you're talking about variability, you need to look at the mean absolute deviations, which means that we need to figure out what the mean absolute deviation for both of these data sets. So the good news is that we already have our means, right? So for data set A, our mean is 27.5. So with all of those numbers, I just need to go through and figure out how far apart they are from 27.5. And I'm just going to subtract everything from it. Then pull open my calculator and type all of that in. Ready? Then type write out all of my answers here. Alrighty, so I have all these new numbers that I have in red. So to find my mean absolute deviation, remember I just need to take the average of all of those. So I need to add all of these together and then divide it by the total number that I added together. So remember to double check these when you're typing them in. And when I add all of them up, I get 61, and I'm going to divide that by 8, because I have 8 numbers. So when I divide it, I get 7.625. So the mean absolute deviation for my first data set is going to be 7.625. Then what we need to do is the same exact thing, but with the second one. So I'm going to rewrite this at the top. For data set A, my mean absolute deviation is 7.625. I'm going to erase all this so I can figure out the next one. Oops. I'm actually just going to pull out Desmos again so that I can do it this way instead of having to rewrite everything out. So for data set B, again, I'm just taking that average and subtracting it from all the points to figure out how far apart they all are. Are you guys still with me on what I'm doing here? Perfect. It's just a long process. It's just a lot of calculator typing in. Oops. 0.25, and then I think scrolling. Okay, so I have 60.5, and I'm going to divide that by 8, and I get 7.56. So my mean absolute deviation for data set B is going to be 7.56. So if I look at these two numbers, are those mean absolute deviations very close to each other? Yes, right. 7.6 and 7.5 are very close to each other, which means that the variability for these two data sets is going to be approximately the same. All right, next one. Next one is showing Mike and Scott, and it looks like they are ice skating judges. Cool. So let me know when you guys find this problem here. Whoops, I dropped my pen. The variability. Remember that we just found the mean absolute deviation, and anytime you are asked a question about variability, you have to use your mean absolute deviation. So mean absolute deviation and variability go hand in hand. And again, let me know once you found this one here. Samples of the scores awarded by 2 ice skating judges, Scott and Mike, were taken. The data for the samples are shown. So these are Scott's scores and these are Mike's. According to the samples, how much greater is Scott's average than Mike's score? So here we are just asked to find the average of both of them and then figure out the difference. So again, we're just going to add up all of the scores. Again, double check when you are typing in numbers. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. And let's do Mike. Ready. So average for Scott was 7. Average for Mike was 6. To find the difference between the two, all we need to do is subtract them to 1. Questions on this one? Alrighty, next question uses data set A and B, and we are given a table. We have the mean and MAD. And again, we want to know which data set is more likely to have greater variability and why. Hopefully we've done this I think maybe the 3rd or 4th one that we've seen. So knowing that this question is asking about variability, that should tell you what part of the data you're looking at. And based off of the number, you should know which one has a greater variability, whether it's data set A or data set B. So when you guys find this problem, look through those answer choices and let me know if you can figure out which one is more varied. Let's see, so Dawson thinks that dataset B has a greater variability and Jordan thinks dataset A has a greater variability. Okay, so with variability, am I paying attention to the mean absolute deviation or am I paying attention to the mean? Which one? The mean absolute deviation, perfect. And if it has a greater variability, whichever number has a larger mean absolute deviation, that data set is going to have more variability. So 24.9 is bigger than 11, which means that data set B is going to be more varied because the mean absolute deviation is higher than the mean absolute deviation for A. So Jordan, does that make sense? Perfect. Awesome. We're almost done. We have I think 3 more questions. So next one is asking us to find the mean absolute deviation for this data set. I think we already found the average for this one, didn't we? We did. So, wait, did we? There's a question where we have to find the average for it. Is it this last one? No, so which means that we already did. So for this data set, the average or your mean was 198.3. So use 198.3 to help you find your mean absolute deviation. And I'll give you guys a second to go through and figure that out for this problem. So remember, for mean absolute deviation, all you're doing is taking your average, your mean, and subtracting it from each one of the numbers in your data set to figure out how far apart the distances from that data point to your average. Perfect, use a calculator. Yes, always use a calculator on these. You should never not use one. Jordan, what did you get? $46.5, that is correct. Dawson, are you still subtracting and stuff? Okay, take your time. Ruben, I should have time to go over that workbook with you, that 21.1. And if you want some help with the other workbooks, we can go through those together as well. Probably tomorrow. We can set up like a one-on-one time if you want to go through those. So Dawson, for this question, we are asking it's asking us for the mean absolute deviation. But we already found the average of this from earlier. So the average we knew was already 198.30.3. So you should get 46.5 for your mean absolute deviation. Okay. And then to speed things up a bit, for this question here, we are given these two data sets and we want to know which one is greater or is more likely to have a greater variability and why. So what we would have to do for this problem is we'd have to find the average of both of our data sets and then do our subtraction where we take all of our numbers and subtract it from that average, and then to find the average of all of those to figure out our mean absolute deviations because it's talking about variability, right? And then from there, we would look and see which one has a higher mean absolute deviation, and whichever data set has a higher mean absolute deviation, that is the one that's most varied. But for time purposes, data set B is going to be more varied. Oh, whoops, sorry, that's the wrong one. I didn't realize there was 5 here. So it's data set B is more varied because the mean absolute deviation is higher. And then after this one, we just have one more question. So let me know when you guys have this answer so I can go on to the next problem. All right, last one. So here we are talking about 2 radio stations, and they randomly surveyed their listeners to find out how many minutes they listen per day. Below are the data from the 2 surveys. We want to know how many more minutes does the median listener of KSQ listen than the median listener of KSOS. So we're asked to find medians here, right? And whenever you're asked to find a median, you should rearrange your numbers to going from smallest to biggest to help you. So that's what we'll do here. here I have KS, KQ. So I'm going to write them from smallest to biggest. Trying really hard to double check to make sure that I don't miss any. Okay, and then let's do KSOS. So again, from smallest to biggest. Let me double check how many numbers I have. So 3, 10 there, 1, 2, 3, 6, 7, 8, 9. I missed one. Do you guys see what number I missed in this bottom one? Is there a repeat somewhere? No, there's the 18 here. I'm missing one. I only have 10 numbers here, and I should have 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm missing one. The 28. I'm going to put a 28 right here. Thank you. Alrighty. So now let's go through, find our median. 33. 35. So we have 43 minus 35. And if I were to subtract those, I get 8. So 8 would be our answer for this problem here. Very last one. Yay, we did it. We made it. We made it through.